Good morning, everyone. Welcome to my end of SEM database management system presentation. I am Swali Bahu, and I'm presenting on an Olympics management system. So, the Olympics is the most prominent international multi-sport competition in the world, and since its inauguration in 1896, they have been held every 4 years. So, the recent games had 204 nations and about 10,500 competitors. And because of this, the Olympics have been expanded in both sides and scope over time. Now, the Olympics database is an online collection of information on all Olympic games and athletes from the first modern games in Athens in 1896. We provide details information on Olympic games, sports, and disciplines. And the database is maintained and updated regularly with the latest information from each Olympic games. It provides comprehensive data on each athlete, including personal information. And the Olympics games, the database also includes statistics on medal counts, world records, as well as the summary of each Olympic Games. It is comprehensive coverage that makes it an ideal starting point for anyone looking to learn more about the Olympic Games and its athletes. Now, this database has six functionalities. One is to store athletes' personal information and his or her relationship with the Olympics. Um, Manage and store information about the team's history in the Olympics. Store and manage data about committee that holds the Olympics, and store data about the staff that each team sends to the Olympics. It also stores data and generate data about the various events that are being held at the Olympics. It also stores data about the medals that have been awarded and who are the athletes that received that medals. So before we created our ERL, we had certain assumptions that a person should either be a team staff, an athlete, a commentator, or an official. And secondly, an athlete can only represent one country or a team. And thirdly, an athlete can participate in an Olympic Games without having a staff member, a team, sorry. And a federation can also represent only one sport and vice versa. So based on the assumptions we had, this is our ER diagram. So firstly, a person can either be a staff, an athlete, a commentator, or an official. Now, which is a generalization specialization, and it's a mandatory or, which means a person should either be one of these things. And an athlete can only represent one team. An athlete can have zero to many medals. An athlete can participate in one or many events. An athlete can participate in one or many Olympics. Now, for the team, a team, based on the assumptions we also had, a team can have zero to many staff members, and a team can have zero to many medals. Now, for the staff, there is a generalization specialization of an optional or. So, a staff can either be a coach, a trainer, or a doctor, or any other specific role. And an event can have multiple, one or many commentators, can have one or many officials, and an event should only belong to one sport. And an event can have one to many records. And events can be participated by one or many athletes. Now, sports can only belong to one federation, and a federation can only have one sport, can only represent one sport, and a sport can have one to many events. That's the relationship that the sport entity has. Now, moving on to the Olympics entity. The Olympics entity can be organized. The Olympics can be organized by only one committee, but a committee can organize one or many Olympic Games. And the Olympic Committee has partners. The Olympic Committee has one or many partners, and the partner can partner with one or many Olympic committees. And there is a specialization generalization here. A partner can either be a sponsor or a broadcasting media or any other partnership, specific partnership. Now, we had about four to many relationships. We had to decompose the both entities, which led us to creating four decomposed tables, which is the committee partner, the event athletes, the event commentator, and the event officials. So based on the relationships the entities had with each other, these are the logical table derivations. We had six, about 7 strong entities and about 10 weak entities. So um, all the attributes that have been bolded, italicized, and underlined in all the tables primary are primary keys, whilst the ones which has been italicized only are foreign keys. So, for example, the person ID has a primary key of the person table has a primary key of person ID, and the team table has a primary key of team ID, and so on and so forth. So with the weak entities, but we have um, certain keys which are both isolized and underlined. For instance, like the staff ID and the athlete ID, which means that an athlete ID is both a primary key and a foreign key. Now, and also based on the entity EER diagram we had, these are the enterprise rules we came up with, which is about 25 enterprise rules. Example is an athlete can represent only one team and so on. After the logical table derivation, we decided I decided to write my queries, which is create the first step was to create tables based on the logical table derivation, and the attributes are assigned to them in the logical table derivation. So for I created a table. The person table has person ID as a primary key, and um, first name, last name as non-key attributes, which is the data type as varchar. So the team too has primary key of team ID, and staff has primary key of staff ID and foreign key of staff ID again due to the generalization specialization, and a foreign key of team ID. Athlete also has an athlete of a primary key of athlete ID and certain some attributes like date of birth, first name, and gender. The team ID is a foreign key in the table, and the athlete ID is a primary key and a foreign key due to the generalization specialization again. Now, the medal has medal ID as the primary key, and athlete ID and team ID as foreign keys. The sport also has sports ID and foreign sports name, number of events as non-key attributes. And moving on to the event has event ID as a primary key, and the sports ID, the sports which it belongs to as a foreign key, and two non-key attributes, which is the event's name and the gender category. The record also has record ID as a primary key, and athlete ID and event ID as both foreign keys. The committee has the committee ID of the committee ID as a primary key, and committee head and Olympic has non-key attributes. The Olympic table has Olympic ID as primary key, and the committee ID as a foreign key. Um, the partners also has partner ID as a primary key, and the partner name as which is the data type vouchers and on key attributes. Since partner due to generalization specialization, we have media and sponsors, which are being derived from the partner table. So we have partner ID as a primary key and partner ID as a primary key and as both a primary key and a foreign key in both tables. So the decomposed tables, which are events, the decomposed table event athletes as event ID and athlete ID as foreign keys. Committee partner has committee ID and partner ID as foreign keys, and Olympic athlete has Olympic ID and athlete ID as foreign keys. Now we have the officials table, which has official ID and official role as a primary key and official role. The commentator to the same thing, they're similar. So there's the change in names. Now, events official, events commentator, derived tables, derived decomposed tables, which has event ID and official ID as its foreign keys. So after that, we had to index 4 tables. So the indexing was based on the index attributes were based on whether they called whether they would be queried later. So in the athlete table, we queried gender, In the sports table, query the sports name, and in the team table, query the team name. In the medal table, we query medal class. We index rather, sorry, we index medal class. After creating our indexes, we updated our tables with data, which you can see below. So the person, the staff, the athlete, the medal, and so on. After populating our tables with data, we host 6 queries. So the first query is about storing information about the athlete. So the athlete records the medal he has won, his name, the sport he plays, his age, his date of birth. Sorry. So let's select that and see what it contains. So it returns the athlete's ID, the sport he belongs, he or she belongs, um, the athlete's name, first name and last name, the team he represents, the medals he has won in gold, silver, bronze, and the records the athlete has broken. So for our team for our second query, just like the first query, we are just storing information about the team's name, the athlete, the athletes, the number of athletes the team presented, the number of medals that the team has won, and the team's ID. So let's run that and see what's yeah. So this is the team ID, the country, the number of athletes the team presented, the number of medals the team has won, and it has classified the number of medals in gold, silver, and bronze. And for our third query, we're just querying the committee ID, the number of partners it's had at that time, and the number of Olympics that particular committee has held or has organized. So let's run that and see what we have. So we can see the committee ID, the committee head, the number of partners, and the number of Olympics it has held. And for the fourth query is about the events. Um, the information about the events, the sports the events belongs to, number of athletes that participated in that event, the number of officials, the number of commentators. So let's run that and see. So yeah, so the event ID, the event name, which is like men's basketball, women's basketball, those kind of things, the gender category of that event, the sports name, the sports ID, the total records that have been broken in that particular sport, the total athlete that participated in that sport, in that event, the number of officials that officiated the event, and the number of commentators that particular event had. So for our fifth query, we're just storing information. We're just storing information about the team that each team presented. So this one is so you can see the team ID, the team, and the number of staff we had. Either a doctor, a coach, a main staff, a main coach, an assistant coach. We just counted everything and placed them in the table. Our last query, we just storing information about the medals. So the medal that have been won, the medal class, the medal ID, the name of the athlete that won that medal, and the name of the team that had the medal. So let's run it and see what we have. So yeah, we have the medal ID, the medal class, the team name, the team that has that medal, the sports name, the sports in which the medal was won in, the medal class, the gender of the winner of that medal, and the first and last name of the medal winner. So this brings us to the end of my presentation. Thank you for your participation.